After a very, very long time of not doing any work at all on the Talking Thermometer project, I finally decided to pick it up again. Now that I have the EPROM player / address finder made, finding the starting and stopping addresses was a breeze. Now, right now, the code doesn't have anything to actually measure the temperature, but the code has programmed the functions to say from a starting address to a stopping address, and then things where I can just put the word in there and then it will automatically to say, okay, this word is this, call the say function with this starting address and stopping, to make it easier. And I just have it just saying some things pre-programmed just to show kind of what it would be like with some kind of crazy temperatures. The EPROM player, if I unplug this, it just plays 2, 3, 4, 5, 6, it just plays 7, from the 8, chip 9, directly, 10, 11, 9, just like 10, I originally 11, showed. 12. But when you plug in this port here, it's connected here to the microcontroller. The microcontroller sends a signal to this load line, pulling it low, which is a load line of the presettable counters inside, which makes the addresses transparent to what's going over here, and therefore the microcontroller takes control. Also, power for the microcontroller is derived from the EPROM player. The idea is eventually the Talking Thermometer will just be a plug-in module that you stick in the side there.
The air temperature is 312 degrees Kelvin. The outside air temperature is 2,634 degrees centigrade. The air temperature is 312 degrees
this has no
Kelvin.
Effect on
the outside air temperature is 2,630.
Oh, that'll actually reset it still, but
the air temperature is 312 degrees Kelvin. The outside air temperature is 2,634 degrees centigrade. The air temperature is 312 degrees Kelvin. The outside
the button and LED are just for testing, and they're not doing anything right now.
134 degrees centigrade. The air temperature is 312 degrees Kelvin.
Here's the chip I'm using, the 4580.
2,634 degrees centigrade. The
I'm not using this though. I tried it and changed things later. I'm using 8 kilohertz, not, or 8 megahertz, not 4, but anyway. It's a work in progress.
The outside air temperature is 2,634 degrees centigrade. The air temperature is 312 degrees.
So far, I do not have the ADC successfully taking in any values. I, thought I programmed it to do that, but obviously the ADC is spitting out absolutely nothing. So right now it thinks it's 0 degrees Celsius, which is dumb, but at least I'll be able to prove a point that when it receives a 0 degrees Celsius value, you'll be able to hear it in the 3 different units, because those parts to decode the numbers seem to be working so far.
The temperature is 0 degrees centigrade. The temperature is 32 degrees Fahrenheit. The temperature is 273 degrees Kelvin. The temperature is 0 degrees centigrade. The temperature is 32 degrees Fahrenheit. The temperature is 273 degrees Kelvin. The temperature is 0 degrees centigrade. The temperature is 32 degrees Fahrenheit. The temperature is
It should say that the temperature is 25 degrees Celsius, and obviously that's not happening.
The temperature is 32 degrees Fahrenheit.
Guess I had some kind of math or coding error or something. referencing some old 2014 code that I made that used the ADC in the past. I found some code in there that made it work. Compare the value on here to what it says.
The temperature is 25 degrees centigrade. The temperature
It's
is
not rounding
7 degrees
right now, it's just chopping off the decimal.
299
Let's
degrees
see what happens
Kelvin.
when I warm it
The
up.
temperature is 25 degrees centigrade. The temperature is 89 degrees Fahrenheit. The temperature is 300 degrees Kelvin. The temperature is 34 degrees centigrade. The temperature is 94 degrees Fahrenheit. The temperature is 300 degrees Kelvin. The temperature is...
Something with the Kelvin is not right. One little else if in the code, and it's working properly with the 300 something.
The temperature is 29 degrees centigrade. The temperature is 83 degrees Fahrenheit. The temperature is 301 degrees Kelvin. The temperature is 33 degrees centigrade. The temperature is 93 degrees Fahrenheit. The temperature is 307 degrees Kelvin. The temperature is 34 degrees centigrade. The temperature is 95 degrees Fahrenheit. The temperature is 308 degrees Kelvin. The temperature is 33 degrees centigrade. The temperature is 90 degrees Fahrenheit. The temperature is 324 degrees Kelvin. The temperature is 47 degrees centigrade. The temperature is 76 degrees Fahrenheit. The temperature is 294 degrees Kelvin. The temperature is 500 degrees centigrade. The temperature is 931 degrees Fahrenheit. The temperature is 772 degrees Kelvin. The temperature is 499 degrees centigrade. The temperature is 931 degrees Fahrenheit. The temperature is 772 degrees Kelvin. The temperature
Those are the
is
max values.
500 degrees centigrade.
Today I discovered two more units of temperature measurement that I didn't know exists. The Rankine and the Raymer. Calculating your Rankine, you can either multiply your Kelvin by 1.8 or add 459.67 to your degrees Fahrenheit. Calculating your Raymer, just multiply your centigrade temperature by 0.8. Since I wasn't really going to be using the words indoor and outside that I originally had on the chip, I replaced those words with Rankine and Raymer and added more coding to use those temperatures. Right now I have the analog to digital converter input simply wired to a trim pot, so I can swing between ground or 0 volts and your almost 5 volts rail voltage, which is really more like 4.89 volts when I measured it. When we have that all the way down, it'll be at 0 degrees Celsius.
The temperature is 0 degrees centigrade. The temperature is 32 degrees Fahrenheit. The temperature is 273 degrees Kelvin. The temperature is 491 degrees Rankine. The temperature is 0 degrees Raymer. The temperature is 0 degrees centigrade. The temperature is 385 degrees Fahrenheit. The temperature is 606 degrees Kelvin. The temperature is 1,092 degrees Rankine. The temperature is 267 degrees Raymer. The temperature is 333 degrees centigrade. The temperature is 632 degrees Fahrenheit. The temperature is 773 degrees Kelvin. The temperature is 1,391 degrees Rankine. The temperature is 400 degrees Raymer. The temperature is 5.
So unfortunately, I still had an error in there somewhere. It was like 1,000 something. 0 isn't a number. Fix the code, no longer says 0.
The temperature is 300 degrees centigrade. The temperature is 591 degrees Fahrenheit. The temperature is 584 degrees Kelvin. The temperature is 1051 degrees Rankine. The temperature is 248 degrees Raymer. The temperature is 300 degrees centigrade.
More progress has been made on the talking thermometer. Now I'm not going to be using this keypad in the final project. This is the keypad to the talking clock, which I borrowed from the clock. Because I'm using the same code for the keypad, but I'm only going to be using 2 buttons. I tried hooking up 2 buttons and was having the worst of luck getting anything to work. I thought that it would be obvious that it should work, but it wouldn't. Once I put the keypad back on, it actually did work. The first option is saying the temperature.
The temperature is 20 degrees Raymer.
Do some filtering there.
The temperature is 20 degrees Raymer.
And then you can set your unit by the 2 button, or by this next button, because I'm going to be having ultimately 2 buttons on the final thing.
Centigrade. The temperature is 25 degrees centigrade. Kelvin, Fahrenheit, Rankine, Raymer. Centigrade, Kelvin, Fahrenheit, Rankine, Raymer. Centigrade, Kelvin, Fahrenheit, Rankine, Raymer. The temperature is 20 degrees Raymer. Centigrade, Kelvin, Fahrenheit, Rankine. The temperature is 537 degrees Rankine.
Let's make it say something in the thousands. By putting a bogus value on, and then the Rankine will get the highest. It's like Kelvin, but Fahrenheit version. Rankine scale is 0 degrees, i.e. 0 degrees Rankine is absolute 0. But it's a temperature scale that's like Fahrenheit.
The temperature is 1,390 degrees Rankine, Raymer. The temperature is 399 degrees Raymer.
Raymer is a temperature scale whose like similar to Celsius, except boiling point is 80 degrees Raymer, and 0 degrees is freezing.
Centigrade. The temperature is 500 degrees centigrade. Kelvin. The temperature is 773 degrees Kelvin. Fahrenheit. The temperature is 931 degrees Fahrenheit.
And then the other buttons just say them for testing.
3, 4, 5, 6, 7, 8, 9, 0, 10, 11, 12, 13, 14, 15.
Professor Farnsworth from Futurama wants to bid you all good news, because the reason why I couldn't get it working right with these buttons was simply a matter of debouncing. I just needed to get a longer delay whenever it first went into the interrupt from these buttons. They were too bouncy. And now,
the temperature is 544 degrees Fahrenheit. Rankine. The temperature is 1,004 degrees Rankine.
we'll put it back to show an actual temperature measurement.
Raymer. Centigrade. Kelvin. Fahrenheit. The temperature is 76 degrees Fahrenheit. Rankine. Raymer. Centigrade. The temperature is 24 degrees centigrade.
Who knows when I'll finally build a box for this thing, because I don't have any perf board on me at the moment. I'll have to order some, but eventually the final device is going to be built into this case with 2 buttons, maybe an LED. It'll plug straight into the side of this. and it will have a jack on the top to plug in a thermocouple. But as far as programming is concerned, the basic circuit design is concerned, for this section, it's working now. Boom!
The temperature is 24 degrees centigrade. The temperature is 19 degrees Reamer. Centigrade. Kelvin, Fahrenheit, Rankine. The temperature is 537 degrees Rankine.
Well, I hope you enjoyed these updates on the Talking Thermometer project. Once I get even more updates where I actually build it into the case, I may do some more video. Who knows when that will be. I'm glad I got working on this though. This has been fun. I got this adapter for the DB25 for here, and it's very useful. If you're wondering where I got this wire, it was old telephone. There was a building that had an old telephone, Western Electric telephone switching equipment for their telephone network, 1970 vintage or so, and it was outdated and was being removed, and they were going to throw all the wire away, and I thought, well, you know what? I'm taking the wire home. I got whole long links of this wire, which has multiple conductors, bell wire too, so it's useful for breadboards as well, and it came in handy for making this adapter here. When you unplug that, it's just the EPROM player.
1, 2, 3, 4, 5, 6, 7,
Just like
8,
the original.
4.
Once you plug it in, it becomes a talking thermometer.
18. The temperature is 24 degrees centigrade.
This has been a Cassette Master production.